Hello again. Here we are for lesson 101. Two sections on this lesson. The first one is multiplication of exponential expressions, okay? So an exponential expression is an exponent being multiplied, okay? So let's just review. 3 to the 5th power means 3 times itself 5 times. So that would be 3 times 3 times 3 times 3 times 3, right? And so if it was noted this way, so if we were going to make it into an expression, it would need to be being multiplied by something. So 3 to the 5th times 3 squared, okay? Now, if your exponential base, okay, the base is the big number, the exponent's the small number. If the bases are the same and we're multiplying, all we have to do is add the exponents, okay? So because these are both being multiplied in exponents or being multiplied exponentially by 3, right? We can use the same base. So 3 and then 5 and 2. 5 plus 2 is what? 7, right? Because if we expanded this out, this would be 3 times 3 times 3 times 3 times 3, right? And then times 3 times 3. How many 3's are being multiplied? 1, 2, 3, 4, 5, 6, 7. So a shortcut to this is just to add the exponents, but only if the base is the same, okay? So let's see how that applies over here for the examples. So 5 times 5 times 5, 5 squared times 5 cubed times 5 to the 4th power. Our base is the same, so we can write a 5, and then we say 2 plus 3 is? 5 plus 4 is 9. So this is 5 to the 9th power. Now, again, 10 to the 15th times 10 to the 17th. Is our base the same? Yes. So 10 and 10, we just write a 10, and then 15 plus 17 is 32. 2 to the 3rd times 5 to the squared. 2 times 5 is 10. 3 plus 2 is 5, right? No, I tricked you. All right, is our base the same? No. 2 and 5 are not the same number. So that means if they ask us to simplify this, this is the most simple that it can get, okay? So you cannot simplify this any further unless you actually want to do the math. So 2 times 2 times 2 is 8, times 5 squared would be 25 times 8, which would be 200. All right? But it's also okay just to leave it like this. The second part of this lesson is on variable bases, okay? A variable is what? It's right, a letter that we use in mathematics that we don't yet know the value of, okay? So variable, and then as a base. So remember, variable base, a variable is the letter, base is the thing that's being multiplied by itself, right? That's connected to the exponent. So it's the same concept. If we have x to the 2nd power times x to the 3rd power, if the base is the same, we just add the exponents if they're being multiplied. So we have 2 x's, which means our base is going to stay x, and 2 plus 3 is 5, okay? So the rule for exponents is if the base is the same, you just add the exponents if you're multiplying. So let's look at an example. We have x times x squared times y to the 17th times x to the 4th times y to the 6th. Now, this is when I really start to like to use colors, okay? So remember, x with no exponent or any number with no exponent just means to the 1st power, right? Being multiplied by itself one time, right? Okay, so x's. Let's look at how many x's we have here. We have x squared, x to the 1st, and x to the 4th. So x to the 1st plus 2, 1 plus 2 is 3, plus 4 is 7. And then we're going to bring down a multiplication symbol, and then we're going to look at our other terms. We also have y's, okay? X's can only go with x's, y's can only go with y's, all right? So if the base is the same, we can bring our y down, and 17 plus 6 is 23, right? Hopefully. Okay? So remember, x's can only go with x's, y's can only go with y's, m's can only go with m's, p's can only go with p's, okay? And they're going to throw a lot of numbers and letters, a lot of letters at you to try to trick you a little bit here. All right, so let's look at the next one. We have a times a squared, m times m to the fifth, a to the fourth, and m to the sixth, okay? So again, I'm going to get my colors out. And I'm going to say, okay, I have an a to the 1 here, and an a squared, and then an a to the fourth. So I'm going to bring my base a down, and 1 plus 2 is 3, plus 4 is 3 plus 4 is 7, okay? So I took care of my a's. Now I'm going to do my m's. So I have an m to the 1 and an m5 plus an m6. So 1 plus 5 is 6. 6 plus 6 is m to the 12th. All right? All right, and that's it. So remember, base has to be the same. Base is the same. Bring the base over to your answer, and then add the exponents if you're multiplying. Multiplication means add. We won't talk about division yet, but I bet you could guess what it's going to be. If multiplication is the opposite of division, what's the opposite of addition? All right, but biggest thing, use colors if you need to. Circle things, cross them out so you know you already collected them. And then make sure you fill in those ones so that you don't forget. The alternative is to expand these out and write a times a times a times m times m times m times m times m, blah, blah, blah. But if you just organize well and add your ones for your variables that don't have an exponent greater than 1, it's a lot easier, and you can just go through and add them, all right? Not Eve, but Adam. My videos still have to have my corny jokes. So hopefully you guys are doing well. That's your last lesson for this week. And we will be moving on to 101 next week. And you will have a quiz that will be posted Monday next week for you to take as well. All right? Hope you're doing well.